Hi everyone. Today we are looking at statistics. Statistics are ungrouped data. Remember I mentioned in part one of ungrouped data that ungrouped data is raw data as you get it from the source. It is not yet grouped and tabulated. Right. So we will be looking at measures of relative standing. With measures of relative standing, we are doing this to determine positions of values in an ordered data. You want to determine positions of values in an ordered data. Okay, ordered data is your arranged data or sorted data from lowest to highest. Okay, so we do this to achieve the goal of drawing the box and whisker diagram. We want to draw the box and whisker diagram. So for the box and whisker diagram, we're going to use Q0, which is the lowest value of the data, in the lower quartile, which is the first quarter of the data, Q1, Q2 as well, which is the median, right? And which is the 50% position, the median, okay, the midpoint value, all right? And the upper quartile, Q3, which is the third quarter of the data, and the maximum value, which is the fourth quarter, which is the last value, the maximum value of data. Okay, so the steps here, the steps that you follow so that you can draw the box and whisker diagram. Step one is to arrange the data in ascending order. So you take your data, you arrange it in ascending order. Step two, you determine the position of the quartile that you are interested in finding. Step three, you find the quartile value corresponding to the position that you got. So here you find the value, write down the value, Q0, Q1, Q3, and Q4. Then step 4, you use the values of these quartiles to draw the box and whisker diagram. Okay, to draw the box and whisker diagram, right? So let us get that. So here we have example 1. Example 1, it has an odd data. The data is odd. The reason they specify that odd data is because when you have an odd data, the workings are a bit different from when you have an even data. Okay, so how do we tell that the data is odd? Well, we know odd numbers, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the data is odd. All right. So they say draw a box and whisker diagram. They draw a box and whisker diagram. Okay. So what do we do to draw the box and whisker diagram? Here's the solution. We're gonna follow the solution to do that. Okay. So step one, remember step one, what do we do? Step one, we have to arrange the data. Step one is to arrange the data. Diagram. Okay. Step one is to arrange the data. So here you arrange the data from smallest to largest. The smallest value is -1. Okay, that's already -4. -4, -3, -3, -1, +1, 2, 4, 5, 6, 10, and 10 again. 10 again. The lowest value is -4, the maximum value is +10. And step 2, what do we do? Step 2, we find, in this case, it's going to be step 2 and 3. I'm going to do them at the same time. So step 2 is to find the positions. So for Q0, we said is the lowest value. The position is the first value, lowest value. Okay, and the Q0 is -4. So the value for the first term is -4. That is 0. And Q4 is the maximum value. 4 is the maximum value, is +10. Okay, so we have Q0, we have Q4, we need Q1, Q2, and Q3. Okay, so for Q1, find the position first, is 1, the first quarter, 1 over 4. This is the formula. 1 over 4 multiplied by into n plus 1. So it gives us the position. Okay, n plus 1. N is 11 because we have 11 numbers. So it's going to be 1 over 4 multiplied by 11 plus 1 is 12. So 1 over 4 multiplied by 12 is the same as 12 divided by 4 is 3. So the third observation is true one. Third observation, meaning the third term, third number on the arranged data is the SQ1. Okay, there's the lower quartile here for Q1. So 1, 3. So the third observation is -3. So Q1 is -3 as shown here. Okay, right. So now go find Q3, the third quarter, right? Where that was the first quarter. Now we are doing the third quarter. So again, the formula is going to be 3 over 4 because this is the third quarter. 3 over 4 multiplied by into n plus 1. N is 11. It's going to be 11 plus 1. So this again is going to be the same as 12 multiplied by 3 divided by 4 equals to 9. Okay, equals to 9. So this is the ninth. So this is to be the ninth term, ninth observation, ninth observation. Okay, so you go, you find that 1, 3, 4, 5, 6, 7, 8, 9. So 2, 3 is 6, positive 6. 3 is positive 6. All right, and then Q2 is the median. The median is the number in the middle of the data. For odd data, it's gonna be the middle number. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the sixth value in this case is gonna be the median. 1, 2, 3, 4, 5, 6 is 2. Even when I come from this side, 1, 2, 3, 4, 5, 6 is 2. So the median is 2. Okay, the median is 2. Positive is positive. Right. Okay, so now we use the data to draw the box and whisker diagram. Okay, gonna use that the quartiles we use to draw the box and whisker diagram. So the box and whisker diagram starts from the lowest value here. That's the lowest value, -4. That's from the lowest value, -4. Okay, I'll just do this so that we draw it together. Starts from lowest value Q0, -4. Okay, Q4 is positive 10. Okay, and then Q1 is 3. 3 is here. Q3 is positive 6. Okay, the ones for the box and whisker, they do not touch the number line. And the median is positive 2 is here. Okay, then you draw the box and diagram like that. So this is the box and whisker diagram representing the data. Okay, representing the data. Okay, so let us look at another example. This is example 2. In example 2, we are given an even data set. An even data set. Okay, so the data is has how many terms that it's given? Let's see, 1, 3, 4, 5, 6, 7, 8. 8 is an even number, so the data is even. So with the even data, we go about it a little bit different. Okay, so the data we are given here. So they say draw the box diagram. So what do we do? The first thing to do is to arrange the data. Okay, arrange the data in ascending order. Okay, so the smallest value is 21. and the biggest is 35. Okay, so we arrange the data in order from the smallest to the biggest, and in order. All right. Step 2 and 3 determining the quartiles. Okay. So Q0 is the lowest value. Q0 is 21. Q4 is the highest value, right? Is positive 35. Now we need Q1. So Q1 is equals to what? We find the position first. 1 over 4 multiplied by into n plus 1. But now n is 8. So when you say n plus 1 is 9, 1 over 4 multiplied by 9, we get 2.25th observation, right? It's 2.25. Okay, 2.25, and for 2.25, we're gonna go and see. So now you see this is not a perfect value because it has a comma here, the point some, right? So what you do is you take that value after the point 0.25, and you check, you're gonna multiply it with the difference of the two values that come after this whole number, the whole number of the term. It's 2 here. So I'm gonna come here and count 1, 2, 1, 2. So it means the first quartile is between somewhere between second term and third term, between 22 and 23, because the position is 2.25. So 1, 2, it's after 2, but not after 3. So it's between somewhere here. Okay, so we're gonna take the difference, this one 0.25, into the difference of those two values, 23 minus 22. 23 minus 22 multiplied by 0.25, and the answer, because the difference here is 1, so when you multiply it with this value, you get 0.25. Okay, 0.25. Then you take the smallest value of these two and you add it to 2.25. Why? Because the position is just after the second observation. So it's going to be 1, 2. Number 2 is what? It's 22. I'm going to say 22 plus 0.25. Okay, 22 plus 0.25. Then I get 22.25. So this means Q1 is 22.5. Okay, 22.25. That is Q1. Okay, and then for Q3, which is what you call that, the third quartile, it's going to be Q3 position is going to be 3 over 4 multiplied by into n plus 1, 8 plus 1, n is 8, remember the number of terms, 8 plus 1, and that is 9 multiplied by 3 divided by 4, and it gives us the 6.75 observation here. Okay, 6.75. So we can see the first value is 6. So it means whatever value it is, it's going to be after 6, right? So here I count 1, 2, 3, 4, 5, 6. 6 is 29, right? 6 is 29. So it means the third quartile is somewhere between 29 and 32, because it's after 29, but it's not the seventh term. So it is between the sixth term and the seventh term, so it's after 29. Okay, so what I'm going to do is I'm going to take the value after the comma, 0.75, and I'm going to multiply it by the difference of those two values, 29. So 0.75 multiplied by minus 29, okay, minus 29. Okay, so I get 2.25. Okay, 2.25. So it means after the sixth observation, I have to add, when I get the value of the sixth observation, I have to add 2. Okay, what is the sixth observation? 1, 3, 4, 5, 6. The sixth observation is 29. I'm going to take 29 and I'm going to add 2.2. 29 plus 2.25 is 31.25. So Q3 is 31.5. 1.25. Okay, so then again you need to find Q2. Q2 is what? Is the median. right, is the median, is the number in the middle of the data set, the arranged data set. With the even data, the median is, we get the median a bit different again. So it's going to say n plus 1 divided by 2, get the observation. So it's going to be 9 divided by 2, 8 plus 1 is 9, 9 divided by 2 is 4.5, observation, 1, 2, 3, 4. So the fifth one, 4.5, is going to be this fourth term, and the fifth term is going to be after 24. 10. So I will say 0.5. So it's going to say this is the fourth term, but then there's a comma, 0.5. I'm going to say 0.5 multiply by the difference of the terms, 27 minus 24, because it is 4.5, it is somewhere. Okay, I'm going to say 0.5 multiplied by 27 minus 24, and I get 1.5. So it means after getting the fourth observation, I have to add 1.5. So what is the fourth observation? 1, 3, 4 is 24. It's going to be 24 plus 1.5. 24 plus 1.5, I get 25 point. I get 25.5. Get 25.5. That is okay. So then I use my data to draw the box and the diagram. Then I use the data to draw the box. Right. Okay. So let us do that. Q0 is 21. Draw a line 21 there. Q4 is 35. I draw a line on 35. 10. And then Q1 22.5. 22. Okay. 22.25. Say let's assume it's somewhere there, just after 22. And Q3 is 31.25. Let's say 31 is somewhere here, because this is 29, 30, 31, 32. So 30, let's say 30 here, 31 is somewhere here, 31.25 is somewhere there. Okay, so then you draw that to the box. You also do the median. The median is what? 25.5, 24, 25, 6, 7. So let's say 25.5 is somewhere there. Then you come there, you plot to the box Whisker diagram. Okay, so that is the box and Whisker diagram. Now we look at the outliers. Okay, so when you have a data set, there's often numbers that do not that just stand out separately from the rest of the data. You'll see when you start to plot the data on a chart, you realize that there are sometimes the data point that is too far from the rest of the other data points, and it is not close to the line of linear regression. When you do the linear regression, a line that shows present the correlation of the data. Okay, but you'll see that shortly. Okay, so these are what we call the outliers. So to get these values, and in this case with relation to the quartiles, what you do is you say these are data points that fall outside the data range of Q1 minus 1.5 IQR, okay, and Q3 plus 1.5 IQR, where IQR is what? Is the interquartile range, the interquartile range. And how do you get the interquartile range? You just say Q3 minus Q1. Okay, so all the data points, all the data that falls outside Q1 minus 1.5 IQR, and the data that falls outside Q3 plus 1.5 IQR, that is what we call an outlier, right? The outliers. Okay, so when you're working with data, what happens is we often speak of the skewness. When we say the skewness of this data, we talk about the distribution measure of the symmetry. When you plot something, let's say for example, if I plot a graph, I plot the data and data representation, and it looks like this, and I will say looks like this, and I will say, okay, well, this is symmetrical about that point, right? it looks about symmetrical. Okay, but sometimes the data can look like this. See, so it is skewed to one side, or it can look like this. You can see the skew, it is moving towards one side, right? So in this case, it is not symmetrical. So data skewness is the distribution measure of the data symmetry. Okay. So when we say data is left skewed, we are saying the mean is less than the median, and the median is less than the mode. Okay, so let's say you have a table like that, and the mean is here. It's a value here. After the mean, you have the median. After the median, you have the mode, right? So remember, the mean is the average of the data. The median is the middle value of the data, and the middle term of the data, and the mode is the value that is repetitive, more that appears more often in data. So if you draw data and it comes like this, see, so we say this is left skew. The mean is less than the median, it's less than the mode. Okay, right? And then if you are talking about the right skewed, in this case, the mode would be less than the mean, the median will be less than, sorry, the mode would be less than the median would be less than the mean. So you can also use the values. For example, if the mean for left skewed, the mean is 5, find that the median is 10, and the mode maybe is 50. So it is left skewed. The mean is less than the median is less than the mode. Whereas with the right skewed, you find that the mode is smaller now, maybe it's 10, and then the median maybe is 50, and the mean, maybe the mean is 20. So you just need to understand this uh, this in here that speaks, right? And if it is symmetrical, you find that the values, if it says symmetrical skew, it means they are approximately around the same point. Maybe the mean is 5, the median is 5.5, you know, 5.5, and the mode maybe also 5, or maybe 5 that, and then you can see that the data is more or less skewed at the same point, all aligns there. Okay, so that is what we say symmetrical skew, right? Okay, so that is what we talk about. So you need to understand that, because sometimes they will ask, is the data left skewed, right skewed, or symmetrical skewed? You need to look at those values and then do the comparison. Okay, so now I spoke about the linear regression. I said outliers, they are outside the zone of the linear regression. Okay, so now speaking about linear regression and data correlation coefficient, the data correlation. So what is a linear regression line? A regression line is a line that best fits the data, right? A regression line is a line that best fits the data. If you have you are plotting data like this, right? You're plotting data like that, right? Then to do a straight line using the information here, you find that the line is like this. So this line, it's a line of best, is the best representation of a line for that appearing data, right? So it is the best, a line of best. That is what we call a regression line. Okay, that is what we call a regression. And look at this point, how far it is from that line. So this would be what? An outlier, as I have explained on the previous page. This would be an outlier because it's too far from the regression. Okay, does not correlate properly with the rest of the information. Okay, so how do we find this equation? Because you can see here the equation is a straight line in this case. How do we find this line, linear regression? Well, you can see it's a straight line. Y equals to a plus x, right? A in our normal equation of straight line is the same as mx plus c, right? Plus c. In this case, c is the same as a, m is the same, and x is x. Okay, so that is just the similarities because it's a straight line. So b can be calculated using the formula on the formula sheet. So on your mathematics paper 1, at the back where the equations, there's a formula for how to calculate. You can use that, and a can be calculated using substitution. So once you have the value of, you can use one coordinate find the value of A, and then similarly to how we find C for a straight line, then write the equation of the straight line. Or you can also get these values A and B by using the calculator. If you know how to get them on the calculator, such as Casio calculator. Most Casio calculators will help you find the equation of the linear regression, the value of A and the value of B. Then you can find the equation. Okay, so that is the linear regression line. The regression line. Okay, so here we speak of the correlation coefficient. Correlation coefficient R. Correlation coefficient. What is a correlation coefficient? Well, a correlation coefficient is a measure of strength and direction for the linear relationship between two variables. Okay, so what, for example, if I just drew on the previous page the line of regression. So let's say if I have a data like this, right, and then I draw a line of best fit, and it appears like that. Okay, it appears like this. So the way this data is, you look at here, you will see that when if this is the x values and this is the y values, when the x value increases, you see this is the first one, second one, the third one, blah blah blah. So just like that. So if the x values increase, the y value also increases. So the relationship is positive. They are directly proportional. When x increases, the y value also increases, right? So that is what we call a relation. It's a correlation in the two variables. When this variable increases, that one also increases. But also in other cases, you may find that the relationship is a bit different. For example, like this. And when you draw the line of best fit, you find that, okay, you can see x starts here with a high y, but when x increases like this, the y values increase, because you can see when I move forward with the x values, the y values are decreasing. So this is also another relationship. So the difference between the two relationships is that one is positive, one is negative. For R, the correlation coefficient between -1 and +1, right? It is between -1 and +1. It starts with -1 and +1. So how do we and you can also use the calculator. Use the calculator. The formula is long, but if you know how to use the calculator for statistics, calculators such as whoever I had already explained on the previous page, you can use the calculator to get R. Use the calculator to get R, the correlation coefficient, and then you then interpret that value that you get. Okay, to interpret the value that you get. So how do you interpret it? Well, if R is less than if R is greater than 0 and R is less or equals to 1. So meaning if you get an R value of anything between 0 and +1, 0 starting from 0 ending at +1, we call that a positive correlation. If you get R being a positive number, R is positive, we call it a positive correlation, right? But if your R, it's a -1 to 0. If R, the value of R is a negative number, we call that a negative correlation. Call it a negative correlation. So what do we call about correlation? It's a relationship. Correlation is a relationship. If I say positive correlation, what I mean is when the x values increase, the y values also increase. That is a positive correlation. Whereas with the negative correlation, we mean when the x values increase, the y values decrease. And the y values will decrease. That is what we mean by correlation. Okay. And if you get R being equals to 0, it means there is no correlation whatsoever. There's no correlation. And R of 0 can be like a horizontal line, straight horizontal line. When the values of x increase, nothing happens to the y because y remains the same. The y value remains the same. It does not increase, it does not increase. So there's no correlation. So in that case, you have R equals to 0. There's no correlation relationship whatsoever that you can. Sometimes that happens, or in another case you find that the information is scattered in a way that there's no way you draw a line. Like you don't know if the line is going to be like that or like that. because the information is scattered everywhere, you are unable to draw a line of best fit or represent the data with a line. So there's no correlation there. So R is going to be 0. Okay. And then, so how do we now discuss the strength of the correlation? Well, what data can have a strong correlation? For example, if you calculate R and the value of R is anywhere from 0.7 to 1, if you calculate R and you get 0.7 or you get 1 or you get 0.85, 0.95, we call that a strong correlation. Right? It's strong correlation. So because it is a positive value, we will say what? Strong positive correlation. 0.7 strong correlation, but it's positive values, so it is what? Positive correlation. So we'll call it a strong positive correlation. Okay. And then if the R value is still 0.721, but now they are negative, then we call that strong negative correlation. Strong negative. Okay. And then for moderate correlation, R will be between 0.5 and 0.7. 0.5, 0.7. So this one will call it a moderate positive correlation. And if those values are negative, we call it what? Moderate negative correlation. Okay. Moderate negative correlation because they are negative. Value is moderate. It's not close to 1 because the strongest correlation is 1. If you have 1, it is 100% correlation. All the information is perfectly on a straight line, like something like that. If all the information falls on this line instead, that is a 100% strong correlation. In this case, would be 100% positive correlation because all the data is exactly on that. Okay, hope that makes sense. Then the weak correlation, if you get anything between 0 to 0.5, then that is a weak correlation. In this case, because they are positive, we would what? Weak positive correlation. But if those values 0 to negative 0.5, that is what? Weak negative correlation. So when you calculate R, you use your calculator, you calculate R, you go to, on your Casio calculator, you go to stats, you put your data, and on your stats, you go to regressions, then you get R. That value of R, whether it is positive or negative, it is between 0 and 1. Whatever it is, you will interpret it using this summary that I created here. Then you either have a positive correlation or a negative correlation or no correlation. And you can tell them that the correlation is strong, it's moderate, or it is weak. Okay, so that is what we talk about when we say correlation coefficient, measure of strength and direction for the linear relationship between variables, because we have one variable that represents the x and one variable that represents y, so that plot. Okay, so that is it with the correlation coefficient. So now what we're gonna do is we need to look at questions. We need to look at questions because questions will allow us to practice. Questions will allow us to practice these terms and understand them better. The more you practice, the more you get them better and perfect and master them. Okay. So now you need to read question papers. Go to question papers, answer question papers, look at the solution. Then you'll be able to relate solutions with what I am teaching you on the tutorial. This will help you to understand them. Please watch the tutorials as many times as you possibly can so that you get and comprehend them properly. And please like, subscribe to the channel so that next time we post videos, you can get the pop-up so that you can get them as fresh as they are uploaded and watch them. Share with others so that the information spreads. Everyone has a chance of understanding the topic. Thank you.